Hello everyone, Sangeeta Nath Sinha is back with a revision series of Class 10 Maths ICSE board. Well, this is in CBSE also, but their exam is already over anyway. So, specifically for ICSE who have certain extra theorems in that. I've already written in 2 questions here, but just I think we'll do a quick recap of the theorems. What are the theorems? See, equal arcs. If arcs are equal, they will cut equal chords. If chords are equal, they'll cut equal arcs. And equal arcs, if arcs are equal, they'll make equal angles, right? So they'll make equal angles at the other part of the circumference. One part is the arc itself. So arc will make equal angles at other parts of the circumference. This you need to just identify the feet of these angles. If the feet are at one point, then the angles will be equal. Okay. Then, what else you have? Okay. Then angle at the center, angle subtended by an arc at the center is twice the angle this arc would subtend at any part of the circumference other than itself, of course. So, if this angle is x, this will be 2x. Just see the feet of these angles. These have to be at one point. Fine. So, this angle will be half of angle at the center, or from here we see angles in the same segment are equal. Now, if this is the diameter, same rule. If it is a diameter, then the arc, which is a semicircle, is subtending this angle at the center, which is 180. So the same arc would subtend half of it, so 90. From where we get that theorem that angles in a semicircle are right angles. Then cyclic quadrilateral is a quadrilateral whose vertices lie on the circumference of a circle. Vertically opposite these angles are supplementary, right? From there we get, suppose this is x, this is 180 minus x. Then this angle will also be x. So in a cyclic quadrilateral, exterior angle is equal to interior opposite, and sum of two opposite angles will be 180. Similarly, if this is y, this should be 180 minus y. This is for cyclic quadrilateral. Okay. Now, tangents. Tangents are perpendicular to the radius at that point. Fine. Tangents are perpendicular. Then, at one point, only one tangent can be drawn. Or if I want to draw another tangent parallel to this one, there will be only another one more tangent that will be parallel to this. So we cannot have more than one tangent parallel to this. Fine. Okay. Then what do we know about? There's a tangent and a chord. Okay. They make an angle. Fine. Now this chord, let me write it in. This chord is making an angle with the tangent. Same, so the chord will divide the circle into two segments. Any chord divides circle into two segments, major segment, minor segment. So now this chord divides the circle into two segments. In one of that the minor segment, it is making the arc, right? So the angle that it would make in the major segment or in the other segment, it's called alternate segment, will be equal. These two angles will be equal. This is alternate segment angle. Fine. Then In a circle, if two chords intersect each other, what will happen? Say AB and CD, they intersect each other. Suppose I join these lines, these points. What do I get? This angle is equal to this. You can see angles in the same segment will be equal. See, both the angles have feet at the same points. See, feet of C is at A, feet of C is at D, that of B is at A. So arc AD is making these two angles. They are angles in the same segment, hence they are equal. Likewise, arc BC is making angle at D, BC is making angle at A. So these two will also be equal. Hence these two triangles are similar. When triangles are similar, the sides are proportional and they will be correspondingly proportional. See, if I mark them as 1, 2, 3, here also opposite to 2 is 2. This is 1 and this is 3, right? So the side made by 1 and 2, if this is not O, this is not the center, we may take it as P. So side made by 1 and 2. So CP will be equal to CP upon PB. The sides are proportional, right? So made by 1 and 2 upon 1 and 2, made by 2 and 3 upon made by 2 and 3 is equal to AC 1 and 3 BD. Okay, or you can cross multiply from these two. You may cross multiply and get CP into PD, right? CP into PD is PB into PB into PA. That's another theorem which you have. So when two chords intersect, then the product of their line segments are equal. Also, if this condition is satisfied, then the points are concyclic. You can use that to prove that the points are concyclic. We have another theorem which talks about tangent and a secant. Before that, tangents from an exterior point, two tangents can be drawn, right? And the length, if this is A and this is B, the length of PB will be equal to length of AB. From an exterior point, two tangents can be drawn and their lengths are equal. Then there's a tangent and a secant. So what can we say about these? A tangent and a secant. What can we say about this? Diameter. This angle will be 90, right? Here if I join this angle is also 90. So from similarity only, we get this. It is PA into AB is PT square. These theorems you already know. It was just a recap. I'll be solving questions and mentioning the theorems I'm using, and I really hope it helps. It's quite a vast chapter, too many questions there, but if you practice or if you already have practiced those questions, then it's not so tough. Start applying theorems, whichever strikes. Start applying. And then you'll come to some point wherein, it will start getting solved. Here the question said, the first one, question says, what all are given? See, two chords are there. They are intersected at point P. This is given to be 9. First proof, triangles are similar. That I already showed, right? Opposite angles, vertically opposite equal. Angles in the same segment equal. That makes them similar. Find CD. So since they are similar, CD by 9 will be 5 by 7.5. And then ratio of, let me just find this. Ratio of area of triangle PAB upon area of triangle PCD. So this is PAB is 7.5 and PCD is 5. This is the area, right? 50. So 25 to 25, 3. Area is square of the sides. So area will be 9 is to 4. Similar triangles areas ratio is square of the ratio of their sides. Right? Okay. These are all PYQs that I pulled up. This one, let us see. See, whatever comes to your mind, start applying that theorem. Always, the first thing that we see, angle at the center, then angle at the circumference. Try to crack that first. So, like AOC is 72. AOC. So, the feet, one foot here, the other at C. Now, let us see another angle which AC is making. Okay, AC is making angle at center. AC is making another angle at circumference. That should be half of it, right? 36 degrees. Whatever strikes, first find out those angles and then come to the question. Sometimes these questions are so guided, they actually help you solve. So now, anyway, since I saw this was 72, I found 36. Another thing I'm noticing, this is a diameter. So angle in a semicircle is 90. Let me mark this as 90. This should also be 90. This much I could mark. Now let me see what they have asked. ABC. ABC 36. I have already found. BAD. BAD. This angle is asked. Okay. Here you can see I've already marked AC is equal to BD. That is given. AC is equal to BD. Equal chords subtend equal angles. So AC subtending 36. So BD should also subtend 36. So BAD is also 36. All right. Then ABD is asked. ABD. This we know is 90. This we know is 36. So we can find from this triangle, you see, ABD. ABD is asked. Now, we already know this is 36. This is 90. This is 36. So remaining should be this. Fine. That will be 90 minus 36, 54. Fine. So the point I was making here is whatever strikes, I will first find out and keep. Then these questions are actually guided ones, From there you can figure out what is asked next. A few more PYQs. Let me see. Okay. Here I have a circle. There is a tangent. There's a tangent. Okay. And tangent is joined to the center. The diameter is joined from here. You can see diameter and tangent. If these two are there, then maybe we can use some of the theorems that we have discussed straight away at times. Let's see. From here, these two are joined and produced. This angle is given to be x. This is asked. Okay, x and y are asked. This angle is given to be 65. Fine. And this is also asked. P, R, Q, T, and S. SRT is 65. SP is a tangent. Find the values of X, Y, and Z. O is the center. So whatever strikes, let me try to find that. First of all, I can see this is Y. So X should be half of Y, right? Whatever strikes, I will first try to write down. This should be 90. Okay. I might have to join this. Let me see. If required, I'll do. Now this is 90. This is Y by 2 and this is 65. So, can we find X straight away? X will be, this is 65. This is 90. So, from this triangle, X is 90 minus 65, right? 25. So, I already got this as 25. Fine. Y is double of that. You can see SQ, this arc is making angle at center. This arc is making angle at circumference. So it is double of that. Now I've already found Y, and then in this triangle, you can see in this triangle, one is 90, one angle is 50. So Z will be 40. Got it? Start finding angles wherever, whichever you think is convenient for you. Let me take one more. Okay, let's see. There's a circle. We have a secant B, A, E. All right. Now center OB and O. Okay. There is another line here, another chord here. These two are joined. This is D. This is O. And there is one more angle here. ABCD. You can see ABCD is a cyclic quadrilateral. In the given figure, this was which year? 2017. In the given figure, O is the center of the circle. DAE. DAE is 70. Okay. Okay. Find angle BCD, BOD, and OBD. These three angles are asked. Fine. Let me see what strikes. See, we already discussed in a cyclic quadrilateral opposite angles are supplementary, right? And exterior angle. In a cyclic quadrilateral, exterior angle is equal to interior opposite. So this angle is 70. This angle will be double of that. So 140. Fine. BCD. Have we found anything yet? Yes, BCD we got as 70 using exterior angle. In a cyclic quadrilateral, exterior angle is equal to interior opposite. Okay. And then angle at the center, which arc is making? BD. The BD arc is making 70 at the circumference. So 140 at the center, right? Okay. Then BOD already we got 140. Now OBD. OBD. Okay, join this. That is simple. These are what? These are radii. So this is 40 total. 180. 180 minus 40. 40. Half of that here and half of that here. So this will be 20 and 20. So OBD is 20. Right? So this is how. Just start applying theorems. Something or the other will come up. The questions I saw PYQs are not so tough, easy ones. Let me see some tough one if I get. Okay, let's see. Here, this thing I think I've done in the CBSE video also. Here we see in triangle PQR, PQ is 24, PQR, PQ is 24, QR is 7. I have talked about Pythagorean triplets. 7, 20. This is 90. This angle is 90. 25 if you remember. Right? See 49, 5, 7, 6, 5, 2, 6. Right? So anyway, this is a Pythagorean triplet. This is 25. The question says, find the radius of the inscribed circle. So a circle is inscribed inside this. Okay. So let's see. A circle is inscribed. You're asked to find the radius of this circle. Here, tangents from an exterior point are equal. So let me take, suppose I draw these. This will also be R because it's a radius. This is r, this is r, 90, so it's a square, so each side is r. Fine. Now if this part is r, the remaining will be 7 minus r, and here the remaining will be 24 minus r. Fine. Now tangents from an exterior point are equal. If this is 7 minus r, this should also be 7 minus r. Similarly, this should be 24 minus r because they are tangents from point P. Okay, and there we get PR in terms of r. So PR is 24 minus r plus 7 minus r, which is equal to 25. Find r. Fine. So 31 minus 2r is 25. Minus 2r is 25 minus 31. You can find this is how much? Minus 6. Minus minus cancelled, r is 3. So this is about tangent from an exterior point. So you can see how you can handle these questions. Whatever strikes, write that first and find the unknown. Should I take a one more which looks little tough, but I think they're all easy only. Let's see. In the following figure, there's a circle, there's a tangent, again it's joined to the center. Okay, same thing, I think, similar one. Diameter, see, similar type of question. This has come in 2010. These two are joined, I think similar type. These two are joined and this is produced. Fine. This angle is given to be 65. Is it the same question? 65. This is E, this is A, B, O, and C. In the following figure, with the center of the circle AB is tangent at point B. B, D, C is 65. Okay. Find BAO. Find BAO. This angle is asked. I think. Okay. What strikes? One thing I know, tangent and radius would be 90. If this is 90, this is 65. This becomes 25. Same question, I think. Anyway, this becomes 25, right? Now, what about this angle? If this is 25, these two angles are equal. See, radii. So this is also 25. Fine. If these two are equal, this is exterior angle to this triangle. So it's 25 plus 25. This we get as 50. Fine. Now come to this triangle. We are done with this. In this triangle, what do we have? This is 50, this is 90, so this should be 40. Similar types. You can see the questions are kind of similar and simple. Just practice a bit, and whatever theorem you know, try to apply that. If you want, write in the comment and tell me if you want me to solve more circle questions. I can come up with circles part 2 and solution of different kinds of circle questions. But then you have to write in the comment box and let me know. Okay? Okay, I hope this should help. Fine. Okay then. Thank you for watching. Watch out for my next video. Bye.